Hi everyone. Today we're going to get into chapter 1 of our textbook. Most of chapter 1 is review material, so I won't go through all the details of chapter 1. However, there are some very key aspects that I do want to cover. We'll try to keep these videos for chapter 1 relatively short. I won't do a lot of examples because a lot of it is review material. However, a few things, especially in section 1.1, a little bit in 1.4 and 1.6, I think we'll get into a little bit more of the detail in those three sections, and then we'll keep some of the other stuff brief. Okay, so first we'll start out in section 1.1. Now, the actual section name is not sets and intervals, but we're going to cover the material for the sets and intervals part of section 1.1. Okay. Now, when we look at numbers in general, you have lots of different types of numbers. You have positive numbers and negative numbers and real numbers and imaginary numbers and natural numbers, and all these different categories of numbers. Okay, you have numbers that are greater than 5 and numbers that are less than 2 and things like that. Okay. And so when we get into these categories, you can write them mathematically. Okay, you can describe them with words, but you can also write them and represent them mathematically. And there's two main ways to do that, actually three main ways. One of them is with a set notation, one of them is with interval notation, the other one is with a number line or a graph, which I think you're probably all familiar with. So we'll utilize that to kind of initiate the idea, and then we'll get into talking about the two different types here. Okay, so let's say we wanted to look at just the numbers that are greater than 5, for instance. Okay, so all real numbers greater than 5. Okay. Well, on a number line, we can represent that pretty quickly. We shade in all the numbers that are greater than 5. And so here's my number line. Every point on the line represents a number, and every number, all real numbers, are represented by some point on this line. Somewhere along the line, there's the number 5. Okay. Now it could be anywhere on the line. I'm just choosing to put it roughly toward the center. Now, if I want to shade in all numbers that are greater than 5, that would be everything to the right, like the number 6 and 7 and 6.3 and 10.75 and the number 2 pi, right? The irrational number would be, out here past 6, it'd be 6 point something. And so anything greater than 5, we would shade in. So we're going to shade in the entire number line greater than 5 to the right, including the arrow, which makes it represent that it keeps going indefinitely. Okay, now on the end point, on the 5, I don't want to include 5 because 5 is not greater than itself. It's equal to itself. And so 5 is not included in this set. So to represent that, we're going to put a parenthesis at the number 5. Now, some of you may have learned this a little bit differently by using a circle. And you can do that, except when you do the homework in my math lab, they're going to use the parenthesis rather than the circle. But some people would put, you shade it in, just a little faster, and then put an open circle there. That's okay. They mean the same thing, but your textbook and my math lab will be using a parenthesis instead of the open circle. Again, it doesn't matter to me which one you end up using. Okay, so that's the number line way to, or the way to represent this on a number line. Now, I said there are two other notations for representing a set of numbers. One is an interval and one is a set. Let's look at the interval for a moment. The interval essentially just takes the left and right endpoints writes them down, and surrounds them with either parentheses or brackets. Brackets are what we use if we include the endpoint. Okay? So in this particular case, the endpoints, the left endpoint is 5. The right endpoint, because this goes out indefinitely, would be infinity. Okay? It's not really an endpoint. It's really a symbol that represents the fact that there is no endpoint. Okay, but we kind of use it like an endpoint. In between them, we put a comma. And then on the ends, we put either a parenthesis to represent the fact that we're not including the endpoint, or a bracket if we were. In this case, we are not. Infinity, because it's not actually a number, we always put a parenthesis on that side because there's no endpoint to include. Okay, so the infinities, whether it's positive infinity or negative if it was going to the left, will always get a parenthesis on it. Okay, so here's the interval notation. Okay, so from 5 to infinity is that set. Now the set notation looks a little bit different. Sets we always surround with braces. A brace is like a squiggly bracket. It's going to look like this. Okay, so these are called braces. And braces go on either side of a set. And in the set, sometimes we just list off the numbers if they're nice to list off. Like if it was the set of integers from 0 to 10, we just write them out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But here, there's too many numbers to list off, right? It's everything greater than 5. It's 6 and 7 and all the decimals and all the fractions, and it goes infinitely large. So I can't list them all off in here. And so instead, we're going to come up with a notation that we call set builder notation. Okay, and now in set builder notation, there are two key aspects. There's what's in the set, and there's the property that they have. Okay, and those key things are separated by a little vertical bar in the set. So on the left we write what's in the set, and on the left we write what's in the set, and on the right we write what property they have. Typically on the left we use a variable. Like I'll put a letter X or a variable X in there. You can put any variable you want. When we start looking at different types of sets later in the course, we may want a specific variable based upon what axis it represents or something like that. Okay, on the right-hand side, we have a property. Now, what property do all of these things have? Well, all of these X's are all the numbers over here that are shaded. All of those X's are numbers that are greater than 5. So I could write that X is greater than 5. It's the mathematical property that all the numbers in that set have. Okay? All right, so again, there's the elements of the set and the property that they all have. Okay, that's our set builder notation. So we have now 3 different ways to represent a set. We have the number line, the interval notation, and the set builder notation. Okay, do one more example. This one will have endpoints on both sides. Okay, so with this next example, let's take a number line. Oh, I don't want to use green. Green isn't showing up well. Let's use blue. Okay, and let's start on the left side by including the point -2. And on the right side, we will have a parenthesis, which means we're not including the number. Well, let's go with a weird fraction here. Let's go with like 103 over 6 or something like that, 103/6. Now that's a number, it's a positive number, but it looks weird because it's a fraction, but that's okay. it's out there. 103 over 6 as a mixed number would be out, I don't know, 10, it'd be somewhere between 10 and 20. Okay, definitely can get it down that far. So anyway, it's out there. And so on this number line, I want to shade in everything in between them. Okay. And so when I write this in interval form, I'm again just going to take the left endpoint and the right endpoint, write them with a comma between them. Okay. Again, it doesn't matter the form of the number. This fraction is not a problem. And I'm writing a weird number there because some of your homework, you're going to be using some weird looking numbers, sometimes fractions, sometimes decimals. They don't always work out to be nice integers. Okay. So just to get you familiar with that. So I've got the left endpoint, the right endpoint, and now I need a symbol to represent whether or not we're including them. So on the left side, I take the bracket because I want to include that endpoint. And on the right, I take a parenthesis because I don't want to include that one. Okay. Again, some of you may have learned this with the circles on the number line. And if you did, that's okay to use when you're doing this by hand. But again, on the computer, on my math lab, you'll want to use the brackets and parentheses. So in this case, a bracket would represent a shaded circle, and a parenthesis would represent an open circle, and our two numbers. And then we shade in between. Okay, so those are the two ways to represent with the number line. Finally, the set notation. Again, I'm going to use the braces on either side. I'm going to put a letter or a variable in on the left. Again, I'll use the letter X, but later in the course we may change it up and use another variable. And then on the right-hand side, I'm going to put the property that describes all the numbers, all the X values that are on this interval. Well, the X happens to be between -2 and 103, 103 over 6. And so I'm going to write a two-part inequality that shows that the X values are both greater than -2 and less than 103 over 6. Okay, so I'm going to write the inequality -2 is less than X, because that's true. X is greater than -2, so -2 is less than X. But also X is less, oh, I'm sorry, that's not true. I need the equal sign in there, because X could also be equal to -2, because we're including it with a bracket. Okay. Now also, X has to be less than 103 over 6. Okay, so I use a less than, another inequality, and so when I put the two inequalities together, it looks like a two-part inequality, right? It has the first representation, which says that -2 is less than or equal to X. It also has the second representation where X is less than 103 over 6. Okay. All right, so that should give us all three forms. We have the number line, we have the interval, and we have the set builder. Okay. And that should cover everything from section 1.1.